All right, today we're going to go ahead and get into section 9.4. All right, in section 9.4, we're going to look for area of regular polygons. All right, so a regular polygon is just a figure that all sides are equal. All right, so a polygon is some type of shape. It could be 3 sides, 4 sides, 5 sides, 6 sides, 7 sides, etc. All right, but regular means that all sides are equal. Now, there's going to be a couple things that we have to make sure we can find when we go to use the formula we're about to learn here. First thing is the apothem or apothem. All right, the apothem or apothem is the distance from the center to a side. All right, the way we look at these is we drop a line straight down from the middle down to a side, and we call that the apothem or apothem. Now, when we go to use this formula we're about to learn, we're going to be forming a triangle first. So we're going to be drawing a triangle with the apothem coming straight down the middle here, okay? Now, when we form this triangle, what we're going to have to do is we're going to have to find this central angle. And the central angle is this angle by the center, by the red curl that we just made in the picture. Now, in order to find that angle, what we're going to have to do is take 360 and divide it by n. Now, in this formula, n stands for the number of sides. All right, so if there's 5 sides, we'll divide by 5. If there's 6 sides, divide by 6, etc. All right, but that's going to be our procedure. We're going to go through some steps when we solve these. But the apothem or apothem is the line that we're going to drop straight down the middle. Typically, it'll be given to us. And then what we're going to do is find that central angle before we begin the problem. Now, again, we said a polygon was a figure with any amount of sides. So here's our polygons right here that we have. Sorry, something in my throat. There we go. Okay, so we've got 3 sides triangle, 4 sides quadrilateral, 5 sides pentagon, 6 hexagon, 7 heptagon, 8 octagon, 9 nonagon, 10 decagon, 11 hendecagon, 12 dodecagon, and you'll notice anything after 12 is an n-gon. So if there's 13 sides, we call it a 13-gon. If there's 21 sides, we call it a 21-gon. We only go up to the names with 12. Now, the ones that we're going to focus on the most in this chapter, we're going to be looking at a pentagon a lot. We'll be looking at a hexagon. Those are going to be the top 2. Occasionally, we'll look at an octagon, and technically, we could do any one of these figures. All right, let's go ahead and look at the formula for a regular polygon, and we'll try to break this down for you. All right, the formula for a regular polygon is given to us right here where it says area is 1/2 AP. All right, we're going to look at it as saying area equals apothem times perimeter divided by 2. All right, that's the same formula, but again, we like to write it like this because the fraction confuses people sometimes in case we have to work backwards. Now, in this formula, the lowercase a stands for the apothem. All right, so when we go to use this formula, we must know what that line drop down from the middle is so that we can plug it in. The P stands for the perimeter. And remember, perimeter is to add up all the outsides of our figure. All right, so we need both of these 2 pieces of info in order to go ahead and solve this. Now, what I'm going to do is I'm going to list some steps for us. All right, step 1, we're going to form a triangle. All right, so we're going to draw a triangle into our picture and form a triangle first. All right, second, we're going to find that central angle. All right, and we're going to do that by taking 360 divided by n. All right, now remember, n equals number of sides. All right, now, after we find that central angle, what we're going to do is remove half of the triangle. Now, after we remove that triangle, we are going to solve using SO, CA, TOA. All right, so we're going to solve for the missing piece, either the perimeter or the apothem or apothem, whichever you call it. All right, after we solve for the missing piece, we're going to make sure that we find the perimeter, P, and we find A, the apothem. Once we have both of those pieces of information, we plug it into the formula. All right, so these are going to be the 6 steps that we want to solve as we go through this. All right, form a triangle first. Do 360 divided by n to find the central angle. Then we're going to remove half of the triangle and either solve for the missing apothem or the missing side to find perimeter. After we find both P and A, the perimeter and the apothem, we're going to go ahead and plug it into the formula. All right, so let's go ahead and look at an example. I'm going to list the formula right over here on the side so that we don't have to keep going back and forth. Apothem times perimeter divided by 2. Remember, we need to identify the apothem and the perimeter before we can do this. Now, let's go ahead and read the question and see what they gave us. Find the area of a regular pentagon with a side length of 4. So they're telling us the side length is 4. Remember, this is a regular pentagon, so right away we can find one piece of information from this. All right, we can technically find the perimeter right away. If all sides are equal and all sides are 4, then 1, 2, 3, 4, 5 sides in this picture, I could do 5 times 4 to get the perimeter. 5 sides times each one 4 tells me P is 20. So we already have one piece of our info. We need to find the apothem, and here's where we're going to go through our steps. Step 1, form a triangle. All right, step 2, find the central angle right here. All right, and the way we're going to do that is we're going to take 360 divided by the number of sides. There's 5 sides. That tells me this angle in here is 72. All right, so we did step 1 and step 2, so here we go. Step 3 is to remove half of the triangle. So what I'm going to do is I'm going to remove half of it, and I'm going to draw it exactly the way I see it right down here. All right, so if I remove that half, let's think about this. The angle was 72, so if I cut it in half, it now was 36. I need the bottom piece of this triangle, and notice that whole bottom was 4, so if I removed it, that little piece should be half of it, so 2. Now, if I'm looking at that triangle, I need that vertical part of it, the line that went straight up and down, because that's the apothem. So I'm going to put an A there so that I know that's my apothem that I'm solving for. All right, here's where I'm going to use SOHCAHTOA to solve it. I'm going to start at the angle. I'm going to go opposite. Across from 90 is hypotenuse, which means this side is the adjacent. I'm going to cross off the H, and I'm left with O and A, so I'm going to solve for this. So tan 36 equals opposite 2 over adjacent. We can call it X, A, whatever you want. Some people use X, some people use whatever. I'll use the A since it's in my picture. Remember, this is a division, so I'm going to do 2 divided by tan 36 and then press equals. When you do that, it tells you that the apothem, if we round it to the nearest tenth, is 2.8. All right, so we have the apothem now, 2.8. We have the perimeter. We have all our pieces of info. We're ready to go ahead and plug it into the formula. Area equals apothem, 2.8, times perimeter 20, all divided by 2. All right, if you calculate that, it's going to tell you that you get 28, and we're talking area still, so we're going to call it inches squared. All right, so there's an example of a pentagon that gave us a side. All right, let's go to another example. This time let's look at a hexagon, and let's look at what happens when they give us the apothem. How is it different? There's our formula, A times P divided by 2. Remember, we need the apothem and we need the perimeter. All right, let's see what they give us. Find the area of a regular hexagon with apothem 12. So this piece is 12. So they already gave us one part of our formula. We need to go ahead and do some work to find the perimeter of this figure. All right, let's follow our steps. Step 1, form a triangle. So I'm going to form a triangle here. Step 2, find that central angle. Find what that angle is up in the middle. We do that by taking 360 divided by the number of sides. There's 6 sides. So that tells us that the angle at the central angle is 60 degrees. All right, so this little angle is 60 degrees. Now let's go ahead and go to step 3. Let's remove half the triangle and let's draw it the same way that we see it. All right, remember that angle got cut in half, so that's 30. If I'm just removing that triangle, the 12 was on this piece. And now remember, we're trying to find perimeter, so I need to solve for the bottom of this. Now, we removed our triangle. We go ahead and set up our SOHCAHTOA. So I go opposite. Across from 90 is hypotenuse. Means this is adjacent. All right, you'll notice it's a tan. So I'm going to go ahead to the side and do some work. Tan 30 equals x over 12. Remember, that's a multiplication. So I'm going to do 12 times tan 30 on a calculator. And when I do that, it tells me that this piece is 6.9. All right, now it was tan again. We're going to use tan most of the time. Technically, we could use sine or cos depending on the picture, but for the most part, our pictures are going to use tangent when we solve these. Now, here's the tricky part. We just solved for the bottom piece of this triangle and got 6.9. All right, let's go up to our picture and let's think about this. The bottom of this piece of the triangle was 6.9. Well, if that piece was 6.9, that means this piece was 6.9. So that means the whole entire side, 6.9 times 2, or 6.9 plus 6.9, tells me the whole side is 13.8. So every single side of this was 13.8. So to find the perimeter, I can take the side, 13.8, and I can multiply it times 6 because there's 6 sides. That will tell me a perimeter of 82.8, and now I have both pieces of info. I have apothem and I have perimeter, so I am set to plug it in. Let's go ahead and plug it in then. Apothem is 12 times perimeter was 82.8, and then I'm going to divide by 2. If you calculate that, it tells you that you get 496.8 centimeters squared. All right, so there's an example of a hexagon, 6 sides that gave us the apothem. A tricky part is be careful with your side. You only found part of it, so you got to double it and then find the whole perimeter. All right, let's go through 2 more examples. Let's look at a pentagon when they give us the apothem. I'm going to go ahead and write my formula. My formula is A times P divided by 2. Remember, we need to know what A is. We need to know what P is before we can solve this. The question says, find the area of a regular pentagon with apothem 8. So we know that piece is 8. So look, they already gave us 1 piece of info. Step 1, form our triangle. Follow your steps and you should be able to get through this. Step 2, find the central angle. 360 divided by 5 is 72. Step 3, remove half of the triangle and redraw it underneath. Draw it the same way so that we can label everything where it goes. 72 gets cut in half to make it 6. 8 was on the vertical piece. Remember, we need to solve for the bottom because we're going to end up trying to find perimeter. Start at your angle, label your sides. Across is opposite. Across from 90 is hypotenuse. Here's adjacent. We're going to go ahead and use tangent again. So let's set this up. Tan 36 equals x over 8. X was on top, so remember this is a multiplication. So on a calculator, we're going to take 8 times tan 36. When you do that, you get 5.8. Now let's think about this. 5.8 was the bottom of our picture. If I were to look back up above, 5.8 is this bottom of that picture. Well, that means this is 5.8, so the whole entire side, the whole entire thing, 5.8 times 2, or 5.8 plus 5.8 tells me each side is 11.6. So to find perimeter, I can take 11.6 times 5 to see what we get for the perimeter. If you do that, you get a perimeter of 58. Well, now we got all the bits of our information that we need, so let's take apothem 8 times perimeter 58 divided by 2. When I do that, I get 232 m squared. Notice when we do our tan over here, make sure you're rounding that to the nearest tenth so that our answers can match as close as possible. All right, let's go through one more example, and then we'll get into some practice. Find the area of a regular hexagon with a side length of 10. Let me go ahead and write down our formula so that we have it. 8 times p divided by 2. Remember, we need to know apothem, we need to know perimeter. They tell us that it has a side length of 10, so let's label our picture. Well, the good news is we can find perimeter right away. Remember, we've always been able to find one piece right away, and then we do our work to find the missing part of the formula. If each side is 10 and there are 6 sides, then perimeter can be found by doing 10 times 6, which gives us 60 for perimeter, so we have the first part. Let's do some work to go ahead and find the other missing piece. I'm going to form a triangle. Next, I'm going to go ahead and I'm going to find the central angle by taking 360 divided by 6 sides, which tells us 60 degrees for that angle. I'm going to go ahead and I'm going to remove half of the triangle, and then we're going to label it with what would go where. My angle was 60, it gets cut in half, so that's 30. I removed half of the triangle, so my bottom piece used to be 10, but now it's only half of it, so it's 5 on the bottom. I need to know the vertical part, the apothem, so I'm going to put X on that side, and now I'm going to do SOHCAHTOA. Cross is opposite, cross is hypotenuse, here is adjacent. Nothing on H, I'm left with O and A, so I'm going to do a tan. Tan 30 equals 5 over X. Remember, that's a division, so 5 divided by tan 30 will tell us that X is going to be 8.7. Now remember, 8.7, that's our vertical piece, so that's our apothem right there. So we've got everything we need now for our formula. Let's go ahead and plug it in then. A equals, apothem was 8.7, perimeter was 60, and we're going to divide that by 2. That will give us approximately 261 for our answer. All right, so again, for this formula, based on what they give us, if they give us the apothem, we're set. If they give us a side, we can find perimeter right away, and then we need to do the steps to find the missing piece. All right, follow those steps each time. Form your triangle. Do 360 divided by n to find the central angle. Remove half the triangle and solve for the missing piece. And then go back and plug in the 2 parts to your formula. All right, we're going to go ahead and do some practice with this now. That is section 9.4.